All right, here's an example that I gave as a practice in class where we're going to go ahead and rewrite the equation from standard form to vertex form, and we are going to do that by completing the square. So the first thing, as I mentioned, when it is in standard form, we can easily see the y-intercept. So I'm going to go ahead and write the y-intercept when x is 0. Y is our constant, which is -2. So our y-intercept is 0, -2. You could see when this is all 0, we are left with -2. All right, to write this equation in vertex form, we are going to complete the square. So the first thing I want to do is add 2 to both sides, and that brings my equation, I will write it up here, to y plus 2 is equal to x squared plus 8x. Next, what we're going to do is we're going to take half of our b value, which is 8. Half of 8 is 4, and square it. So I'll write it right here. We're going to take half of 8 and square that. That will give us 4 squared, which is 16. So we're actually going to be adding 16 to both sides. So I'm going to add 16 on the right and 16 on the left. Let's go ahead and combine the left. We will have y plus 18 is equal to, and I'm going to go ahead and factor this already. This will give us x plus 4 times x plus 4. Now to refresh your memory, we have a perfect square trinomial. So two numbers that give us 16 that add up to 8 is 4 and 4. And if you remember, that is half of our b. Factoring this, we have y plus 18 is equal to x plus 4 squared. And then we will subtract 18 on both sides. So our equation in vertex form will be y is equal to x plus 4 squared minus 18. Okay, now let's go ahead and write the main characteristics. So once we have our equation, we can go ahead and see that our vertex happens to be -4, -18. So -4, -18. Our axis of symmetry is always the first value of our vertex, which in this case is -4. So our axis of symmetry is x equals -4. Now how this graph shifts is 4 left and 18 down. Let's go ahead and check mentally if our y-intercept matches. If I put 0 in here, 0 plus 4 is 4, and 4 squared is 16, and 16 minus 18 is indeed -2. So it looks like we have matched that correctly. So I have my axis symmetry is at -4, so I'm going to go ahead and draw a vertical line at -4. This is my axis of symmetry. And go ahead and put the vertex at -4, -18. Now I know this is way down, so if we want to be a little bit more accurate, we can go a little bit more down. So I'll just extend this graph, or we can change the scale of this graph, but I'm just going to go ahead and just do -12, -14, -16, -18 is right here. So my vertex is at this point, and my y-intercept is at 0, -2. So I'm going to go ahead and put the point there. Now let's count how many units to the right we are of the axis of symmetry. We are 4 units to the right, so that means I will have 1, 2, 3. I'll have a point 4 units to the left, because the line of symmetry is your axis symmetry divides your graph into half. So let's go ahead and make a best as we can sketch of the parabola. Make sure it is a U-shaped graph, not V. And there we go. Now, if you remember, I have mentioned that if our A value is 1, the parabola will have the pattern of going up 1, right 1, and then up 3, right 1, and then up 5, right 1, like that. So we can always do that if we want it to be more accurate. All right, so the last thing we want to talk about is the domain. The domain for this parabola and all parabolas is all real numbers. So we can say all real numbers. And our range always depends on our k value, which in this case goes as low as -18. Look at right here. So our range, always we read it going up and down. And so our range starts at -18 and then goes up. So we can say that y is greater than or equal to -18. This is using an equality notation. If you wanted to use parentheses, you can also say square bracket -18, because it does include -18, comma, positive infinity, round bracket.